Next problem, from the adult population, for large cities, random sample was selected and the number of married and unmarried men were recorded. We have 4 cities A, B, C, D, corresponding married and single, number of married and single men recorded, frequency recorded. We needed to check the 4 cities, in the among cities, have any variation of tendency of men to marry. Okay, so given that this is the problem, okay. So we take a given table. So A, B, C, D, 4 cities. Given that married and single persons, we take the total. This row total, this row total. Similarly, this column total, this column total, this column total, and this column total. Next, we need to find, this is the observed frequencies. Next, we need to find expected frequencies. How to find an expected frequency? We already say in the case of 2 cross 2 contingency table, expected frequency of A is A plus B into A plus C divided by total. Similarly, here expected frequency of 137 is this row total into first column total divided by n. Therefore, 169 into 600 divided by 780. Total is 780. So, first expected value is 169 into 600 divided by 780. Similarly, next is first row 600 and second column 221. So, 600 into 221 by 780. Similarly, next 600 first row and third column into 208 divided by 780. Next is 600 first row and 182 fourth column divided by total 780. Similarly, this second row total 180 into first row, first column 169 divided by 780. Similarly, 180 into 221 divided by 780. 180 into 208 divided by 780. And 180 into 182 by 780. So, we get these values. And you find out the exact value of these. You got 30, 39, 170, 51, 160, 48, 140, 42. Okay. You got expected frequencies are these. Then you write down the observed frequency, expected frequency table. 137, 32, 64, 57, 152, 56, 147, 35. Corresponding to observed frequency, you write down the expected frequencies. 30, 39, 170, 51, 160, 48, 140, 42. Okay. Now, get observed frequency and expected frequency. Next, you find out O minus E square and O minus E square by E. O minus E square. 137 minus 30 is 107. Sorry, here 130. Sorry, 130. Okay, 137 minus 130 is 7. 7 square, 49. Here 32 minus 39, also 7, 49. Here 164 minus 176, 36. 57 minus 51, 6, 36. 152 minus 168, 64. 56 minus 48, 8, 64. 147 minus 147, 49. 35 minus 42, 7, 49. Next you find out 49 divided by 130. That value is 0.4. 49 by 39, 1.3. 36 by 170, 0.2. 36 by 51, 0.7. 64 by 160, 0.4. 64 by 48, 1.3. 49 by 140, 0.4. 49 by 42, 1.2. Okay, you got O minus E square divided by E individually. Next you find the column total. This column total, that is 5.9. So this column total is chi-square statistic. Sigma O minus E square by E is 5.9. So calculated chi-square value is 5.9. Next you find the tabled value. So first you find degree of freedom. Degree of freedom is R minus 1 into C minus 1. R is number of row. Here number of row is 2 and the number of column is 4. So R is 2 and C is 4. So you give in this formula 2 minus 1, 4 minus 1, 1 into 3. So degree of freedom is 3. Here didn't give level of significance. So you take level of significance alpha equal to 0.05. So in the chi-square table, degree of freedom 1, 2, 3 and level of significance 0.05. Corresponding 3 and 0.05, you go to the value. That value is 7.82. 7.82. This is the table value. Table value is 7.82. You get calculated value 5.9 and tabled value 7.82. So here calculated value is less than table value. So therefore we accept null hypothesis. Our null hypothesis is there is a homogeneity. So we accept null hypothesis. H0 means we conclude there is homogeneity. That is, 4 cities are identical. Okay. Our question is there is a significant variation among the cities in the tendency of men to marry. So we can conclude that there is no significant variation among the cities in the tendency of men to marry. Because of there is a homogeneity in 4 cities. That 4 cities are identical. So there is no variation among the cities in the tendency of men to marry. Okay.